Assalamualaikum. Hi and welcome everyone. I'm very excited to have you here as we begin a new subtopic in our engineering science journey. Today, we will be learning about coplanar and concurrent forces. Learning outcome for this subtopic is to define and solve problems related to coplanar and concurrent forces. Let's take a look at two important types of force systems, coplanar forces and concurrent forces in this slide. On the left diagram, we see an example of concurrent forces, and on the right diagram, we have an example of coplanar forces. Concurrent forces. Concurrent forces are forces whose lines of action all pass through a common point. The forces acting on a point object are concurrent because they all pass through the same point. Concurrent forces are two or more forces that act at the same point. Key characteristics of concurrent forces. They may act in different directions, but all forces intersect at one point. It can be in 2D or 3D space. You can resolve them using vector addition to find the resultant force. Now, let's explore three real-world examples of concurrent forces in construction. Example 1. Roof truss joint. At the joint of a roof truss, multiple structural members meet. Each member applies a force toward or away from the joint. These forces converge at the connection point where they balance each other to stabilize the structure. Example 2. Crane lifting a load. When a crane lifts a heavy load, several forces act together at a single point. The tension force in the crane's cable pulling upward, the gravitational force pulling the load downward, and sometimes wind forces acting sideways. All these forces meet at the load hook, making this a clear example of concurrent forces. Example 3. Scaffold connection point. At scaffold junctions, vertical and diagonal members apply forces at the same node. The vertical force from the weight above, the horizontal force from bracing, and any external loads like workers or materials, all combine at a single joint, showing concurrent force behavior. Coplanar forces. Coplanar forces are forces that lie on the same plane regardless of whether they are concurrent or not. Key characteristics of coplanar forces. All forces exist in a single plane, usually 2D, x and y plane. They may or may not be concurrent. It can be parallel, intersecting, or non-intersecting within the plane. Let's understand coplanar forces in construction using three simple examples. Example 1. Wall and beam system. In a wall and beam structure, the weight of the wall applies a downward force on the beam. The beam provides an upward reaction force to support the wall. Both forces act in the same vertical plane, making them coplanar forces. Example 2. Bridge deck. On a bridge deck, traffic loads, the self-weight of the bridge, and wind forces act across the surface of the bridge. All these forces lie within the same horizontal plane of the deck, classifying them as coplanar forces. Example 3. Floor slab. For a floor slab in a building, the load from people and furniture creates downward forces. These are balanced by the upward reaction forces from supporting columns or beams. All these forces act within the same horizontal plane of the slab. In each example, the key point is coplanar forces act within the same flat surface, either horizontal or vertical, depending on the structural element. Now, let's learn on how to solve concurrent forces. Concurrent forces can be resolved using vector addition to find resultant force. The first step is you have to draw a free body diagram. The second step, resolve forces into x and y component. Third step, total force along x and y axis. Fourth step, calculate resultant force and its angle. And last, you have to draw complete resultant force diagram. This is an example of concurrent forces. Given three concurrent forces acting on a bracket, what you have to find is the magnitude and angle of resultant force. Show resultant in a sketch. So let's try, students. All the best. Thank you.